at Preston School. I just wanted to do something for you guys. I know that you're out of school and you're going to have to go to interactive learning. And this is something we're having to do at OSUIT also. And so I've been making a lot of videos, and I was just thinking about you, and I wanted to do something for your math and science classes that you might be able to incorporate in those classes. So you've all bought light bulbs, and if you've bought light bulbs, you have noticed that you buy light bulbs rated in wattage. So the question is, how do we know how many watts a light bulb actually is producing? And so I've set up a little demonstration here that's going to show you two different tools that we use all the time in electrical and air conditioning, refrigeration, electrical engineering. That's a voltmeter and an amp clamp, which is an amperage meter. And looking at a couple of formulas here, this is called Ohm's Law. Ohm's Law is made up of many formulas, but two really important ones. The simplest two say that if we know the voltage and we divide the voltage by the amperage, we can get resistance. Or if we take the voltage and divide it by the resistance, we can get the amperage. Or if we take the amperage times resistance, we can get the voltage. And this is called the power formula. If we want to know wattage, we can take the amperage of a circuit and its voltage, multiply them together, and see how many watts that it's producing. So I've wired up 3 light bulbs here, and it just so happens that they're wired in parallel. And so amperage actually is the total of all 3 of the amperages of these bulbs added together. That would be the total amperage of this circuit. So I've already got a voltmeter here showing me how many volts that we're producing, or how many volts that we're using to energize the light bulbs, and it's 124 volts. So voltage, we're going to use this formula right here to find our wattage. If we take 124 volts and multiply it times our current, we're going to use this amp clamp right here to measure our current, put it on volts or amperage AC, go to our main wire feeding everything, and we can see that our total current is 0.32 amps. 0.32 amps. Now I've already done the math here. I'll do it again just in front of you so you can see what I'm actually doing. I'm going to my calculator here, and I'm going to punch in 0.39 times 124 volts, and see that my total wattage equals 48.3 watts. Well, it just so happens that this light bulb, same light bulb that we have right here, this light bulb is a 15-watt light bulb, and so it proves that really close. We know that if this is a 15 and this is a 15 and this is a 15, that should total 45 total watts, because wattage increases in a parallel circuit. And so we proved that a 15-watt light bulb is really close to an actual 15-watt light bulb. So you may ask, what's the difference? Well, most of the time we utilize 120 volts. You can see that we're measuring it very precisely here, and it's actually 124 volts. So we're a little bit high, and that's why we end up with a few more watts. So we could do the resistance with the same demonstration. Now that we know the voltage, 124, and we know the amperage, we could take 124 volts and divide it by 0.32, and that would give us our total resistance in that circuit. 124 divided by 0.32, we have 387 ohms. Okay, so that's something that you can think about, brainstorm a little bit, and maybe your teachers can add a small assignment to that. I know your teachers are missing you, and look forward to seeing you again. Y'all enjoy your break. Stay safe. Bye-bye.